Previously, we tried to analyze this situation in which we place a 5 kg block on a rough surface and we pull this block here at an angle of 30 degrees above the positive x-axis with a force of 50 Newton. Then from there, we analyze this system by drawing a free body diagram to illustrate all the forces acting on an object. Then we determine the magnitude of all these forces that are acting on an object, and the magnitude are listed over here. Then we use this magnitude of forces here to calculate our work done, and we do it one by one, finding the work done by external force, by weight, by normal, and kinetic friction. And we notice that all work done that we have calculated here can be either positive, zero, or negative. So in this video, we are going to explore further what does it mean if our work done is positive, zero, or negative. So for this video, we are going to pick 3 examples, which is the work done by external force, by weight, and kinetic friction to study further, because these 3 work here are either positive, zero, or negative. So let's shift things around. I bring my work done by external force here, work done by weight here, and work done by kinetic friction. You can see that their answer is either positive, zero, or negative. So this diagram here is a diagram which I use to determine the angle between the force and the displacement. So you can see 30 degrees here is the angle between the external force and the displacement. 90 degrees here is the angle 90 degrees between the weight and the displacement, and 180 degrees here is the angle between the kinetic friction and the displacement we have here. So let's study further what causes this work done to be positive, zero, or negative. We can see that for the first case, work done by external force, the answer is positive. We know F here is a magnitude of force, so magnitude of force is a magnitude of vector, so it must be positive. Displacement here is a magnitude of displacement here, it's a magnitude of a vector again, so it must be positive as well. So the first 2 parameters that we have here must be positive. So if there's anything that changed the sign of the answer, it must be because of the cosine that we have back here. So back here we see that the angle is 30 degrees, and we know from our trigonometry that if our angle is between 0 and 90 degrees, not including 90 but including 0, our cosine will be a positive value. Okay, remember ASTC, all positive from 0 to 90 degrees, not inclusive of 90 degrees. So what does it mean is, if our work done is positive, it means that the cos function that we have here generates a positive answer. We can generate a positive answer for our cosine function only if the force has a component in the direction of displacement. So you can see here, this force here, if you resolve it, the component of the force parallel to the displacement is in the same direction as the displacement. Then you can see this will be a positive value multiplied by a positive value, therefore you get a positive value. Okay, for the next example, you have a work done by weight. So for work done by weight, you can see that the angle is 90 degrees, and in the first 2 parameters, the weight and the displacement, the magnitude of weight and the magnitude of displacement, they are both positive. So these are not the one that cause it to be 0. The parameter that cause it to be 0 is the cos 90 at the back. So cos 90 based on trigonometry equals to 0, and that is the parameter that cause it to become 0. So in what situation will your work done be 0? Your work done will be 0, or you do no work when your force is perpendicular to the direction of displacement. You can think of it this way: if your object is moving to the right, pushing an object up or down, doesn't affect the motion to the right. It may cause the object to move upwards or downwards. Yes, that's another thing. But motion to the right is not affected by forces exerted upwards or downwards on the object. The same case, object moving upwards and downwards is not affected by forces pushing to the left or to the right. The x dimension and the y dimension are independent of each other. So for the third case, you have a work done by friction. This work done by friction here, you can see that the magnitude of kinetic friction and the magnitude of displacement, they are both magnitude of vector, so the value should always be positive for the first 2 parameters. But for the last parameter, cos 180 degrees, that's the one that provides the negative sign to our answer over here, because cos 180 is -1. Therefore, you get a negative answer. So your answer will become negative if your cos theta here generates a negative value. And cos theta will generate a negative value if your angle is between 90 and 180, not inclusive of 90, but inclusive of 180. So at that situation, you will see that the cosine will generate a negative value, therefore causing your work to be negative. So your work done is negative if your force has a component opposite to the direction of displacement. So as you can see over here, this force here is not parallel with the displacement. But even though it's parallel, the component here, the force over here is in the opposite direction to the displacement. So if it's opposite, right, your F parallel is a negative, your displacement is a positive. So negative times positive becomes a negative value. Because F cos theta here represents F parallel. So F parallel is pointing in the opposite direction. So F parallel is a negative value over here. Okay, so this apply also even for angles like 135 degree, 150 degree, 175 degree. At those angles, even though you are not directly opposite, if you resolve the force will have a component which is opposite the direction of displacement. As long as your force has a component which is opposite the direction of displacement, your work done will be negative. So we have summarized things out over here. Work done positive, the force is in the direction. No work, perpendicular. Work is negative, opposite to the direction of displacement. So now let's move on to study further about what does this work done represent. If work done is positive, what does it really represent? What we mentioned is work done is positive because the angle between the force and the displacement is less than 90 degree. Therefore, it is positive. That's the cause. But what does it mean when the work done is positive? What does it mean when the work done is 0 or negative? This is what we are going to investigate now. So work done is positive. You can see that the force has a component in the direction of displacement. So you can think of it as the force itself is helping the motion. The force itself is directly causing the displacement, or you can say it's facilitating the displacement. So the force here is facilitating the displacement. It's making the displacement happen. It's causing the displacement. It makes the displacement easier. You can think of it like that. Okay. So what do we mean by facilitating, right? In an energy way of explaining things is energy is transferred to the body. Let's say this force here is exerted by me pulling on the block. So the food that I eat, the chemical energy that I have stored in my body will be transferred and used by me or supplied to the body to cause the body to move. So the energy is supplied by me to the body. Energy is supplied to the body. Okay, so for no work, you can say the force is irrelevant to the displacement. There is displacement happening, but this displacement, the force over here is irrelevant to the displacement. It might be useful for other stuff, but it's not relevant for this displacement because it's 90 degree. The motion over here is not related to the forces over here. So yeah, not related. Okay, next one, we have your work done is negative. If your work done is negative, you can see that the force is in the opposite direction of the displacement. So if something is moving to the right but you're pushing to the left, of course you are not helping the displacement, right? In fact, you are making the displacement harder. So you can think of it as the force is hindering the displacement. It's making it more difficult to move in that direction. So in an energy sense, what does we mean when we say hinder the displacement is energy is transferred out of the body. Well, let's say for this situation here, you have your friction, right? So friction is exerted by the surface on the block. When you place a block on top and you slide it to the right, the surface over here will exert a force to the left, trying to make the motion to the right more difficult. So when I say transfer out of the body, what does it mean? Well, it's a bit complicated. The mechanical energy of the block, which is the energy associated to motion or position. So the object here is moving. It has its own kinetic energy. It has its own potential energy. So what does this friction do? This friction will transform a portion of this mechanical energy out to another form of energy, which is the internal energy. So when it's transformed to internal energy, what will happen is it will rise the temperature of the body, making the body hotter. That's why when you rub your hand, your hand will feel hot. When you rub something across the surface, the object surface will feel hot. is because the mechanical energy, the sum of kinetic energy and potential energy, a portion of it is being transferred into another form, which is the internal energy, thus rise up the temperature of the object. So you can see energy coming out, making the displacement even harder. If we supply energy to the body, it helps the displacement. That's what we mean by facilitating the displacement and hindering the displacement. So these are we can explain work in the way of saying that it's a transfer of energy, and this is how we interpret when our work done is positive, zero, or negative.